Welcome everyone. In this video, we're going to work out the sample final exam for Math 195. This is a pre-calculus sample final, so hopefully you have seen a lot of these topics in your pre-calculus course. Do not use any electronic devices as you work through the test. I will leave a PDF file of this test in the description box. That way you can work out the questions first before you dive into the video. All right, let's get started. So we're going to call this folder solutions. All right, so for the first one, we're going to evaluate and simplify this expression into one fraction. So there are multiple ways to do this. I'm going to go ahead and distribute. So that's my way of working out this question. So we have 2 over 3 times 6. You can write 6 over 1 minus 2 over 3 times 3 over 2, and then minus 1/2. All right, now let's simplify. So this one, you can reduce the 3 and the 6. That's going to give you a 2. So 2 times 2, that's going to be a 4. Minus, now for this one, if you simplify, you can think of canceling out 3 and 3, 2 and 2. That's going to leave you with a 1. And then we have minus 1/2. All right, now 4 minus 1, that's 3 minus 1/2. Now here you want to put them in common denominators. So write this as over 1 multiplied by 2 over 2. And this will give us 6 over 2 minus 1 over 2, which will give us 5 over 2. So there you have it. Our answer is 5 over 2. Okay. All right, let's move on to the next question. So for the next question, we're going to simplify this expression, eliminate any negative exponent. So again, there are multiple ways to do this problem. I'm going to go ahead and simplify the inside here first. So my goal is to turn these negative exponents into positive exponents. So I'm going to swap their places. So here's where I'm going to have everything to the second power. So 2 can stay on the numerator. A to the first can go on the denominator. B stays on the numerator. A to the third stays on the denominator. B to the negative 4, which is in the denominator, goes on the numerator. Okay, so carefully I have done that. Now I combine by using laws of exponents. These I'll combine, and these I'll combine. So you'll have everything again to the second power. You have 2, B, you add the exponents, this is 5, and A's, again, you add the exponents, you get to the 4th power. Okay, now we can again use the laws of exponents to take care of this power. So we distribute this power to every power here. So we'll have 2 to the second power, that's 4, B to the 5th to the second power, that's 10, over A to the 4th to the second power, that's A to the 8th. And there you have it. That's your final answer. 4, B to the 10th over A to the 8th. That is our final answer. Moving on to the next problem. We're going to go ahead and expand this and simplify. So again, the power means you have the same term twice. So we're going to go ahead and do that, expand that. So you'll have 3 minus 5y times 3 minus 5y. So again, distribute this term to that term, this term to that term. So this is equal to 3 times 3, that's 9. 3 times negative 5y, that's negative 15y. And then negative 5y times 3, that's another negative 15y. Negative 5y times negative 5y, that's positive 25y squared. Okay, so here we can combine these guys because they're like terms. So we have 9 minus negative 15, that's negative 30y plus 25y squared. So there you have it. That is our final answer to this problem. Goes here. All right, moving on to the next problem, verify this identity. All right, so here you do need to remember some of your identities, trigonometric identities. So we're going to start with the left-hand side. This is your left-hand side, and this is what we call the right-hand side. So you want to start with one side, show that it is equivalent to the other side. So I'll start with the left-hand side. So this is a proof. So the left-hand side is 1 over 1 minus sine square of t. Now I know this is an identity. So we call the identity that sine square of t plus cosine square of t is equal to 1. So using this identity, we're going to go ahead and try to make it into this expression. So it looks like I need to subtract sine squared t. So you're going to have cosine squared t on the left side is equal to 1 minus sine squared t by simply subtracting this from both sides. All right, so that's what I'm going to replace right here. This is equivalent to cosine squared t. So we have 1 over cosine square of t. Well, 1 over cosine squared t, that's equivalent to secant squared t. And we know this is one of our identity. This is equal to 1 plus tangent square of t. And this is our right-hand side. So we have completed the proof. All right, for next number 5, cosine of 75 degrees. We can rewrite this angle right here as 45 plus 30. So we know this is equivalent to, so cosine 75 degrees is equivalent to cosine of 45 degrees plus 30 degrees. So I chose to use the sum formulas for cosine to evaluate this. And using that formula, we know this is cosine of 45 degrees, cosine of 30 degrees, minus sine 45 degrees and sine 30 degrees. And from memory, we know these values. Cosine of 45, that's square root of 2 over 2. Cosine 30, that's going to be square root of 3 over 2 minus sine 45, we know the value is square root of 2 over 2. Sine 30, we know the value is 1/2. And then you combine them. So this is square root of 6 over 4 minus square root of 2 over 4. So you could leave your answer like this if you would like, or you can put them in a single fraction like this, square root of 6 minus square root of 2 over 4. So another way to write the same answer. All right, for number 6, we're going to evaluate this. So I have a negative exponent. I turn it into a positive exponent by writing 1 over 27 to the power of 4 over 3. And then the power 4 over 3 can write it as a radical. This is 1 over cube root of 27, raise it to the power of 4. And now you evaluate this, cube root of 27. Well, we know that's 3, so this is 1 over 3 to the power of 4. 3 to the power of 4 is 81, so this is 1 over 81. So that is our answer for 6. All right, now we continue to the next problem, number 7. We want to solve for this equation. This is a trigonometric equation where our solution must be within this interval from 0 to 2 pi. All right, so let's go ahead and isolate our trig expression, which is tangent theta. So we're going to go ahead and add 3 to both sides. So that's going to give us tangent squared theta is equal to 3. And then to get rid of the square, we take square root on both sides. So that will give us tangent of theta is equal to plus and minus square root of 3. So remember, every time if you take a square of a square root, you get 2 different values, plus or minus. Okay, all right, now let's see what is theta. So we want to know what is our theta value. So that way tangent of that theta give us positive square root of 3 or negative square root of 3. Now we need to go back to the unit circle and get that. So let's suppose here's our unit circle. Let's go ahead and draw that. Now you don't necessarily have to draw the unit circle. You can just write down this acronym. So we know ASTC. So we know our 2 values, 2 angles are going to be positive, one here, because that's where tangent is positive. So that will correspond to the positive square root of 3. And then this quadrant and this quadrant tangent is negative. So we're going to get the other 2 solutions in the second and the third quadrant. So we'll have solution in every quadrant. So we're going to go from 0 all the way to 2 pi. That's what this restriction means. Okay, so let's find the angle on the first quadrant. So we know that in quadrant 1, theta must be pi over 3, because we know that tangent of pi over 3 will give us square root of 3. So we know that's why this angle must be pi over 3. So that's one angle, one value. So we know one of our angle that has to be pi over 3. Now the second angle we want, now you could get this one right here, but it's okay if you go for the one in the second quadrant because that'll give us the corresponding negative square root of 3. So now I want this angle right here because that's going to give me a negative value for tangent. What is that angle? Well, you can use pi over 3 as a reference angle. So now in quadrant 2, we know our theta must be pi minus the reference, which is pi over 3. That's going to be 2 pi over 3. Why is that? Well, because again, you can check tangent of 2 pi over 3 is going to be negative square root of 3 because you're going to use the reference angle pi over 3. And because of ASTC, second quadrant tangent is negative. So check. So another angle that we're going to write down as our solution is 2 pi over 3. And you just keep on going. Now you want the angle, the next angle on the third quadrant. So the third quadrant, we want this angle right here. So there are multiple ways to get this angle. One of the way you can get it is simply in third quadrant, you do pi plus the reference, which is pi over 3. So that's going to give you the positive square root of 3. So again, there's two places where tangent is positive and negative. So the next angle will be 4 pi over 3. And the last angle we want is the one that will lead us in the fourth quadrant using the reference pi over 3. So next angle we want is this one right here. So this will go around and terminate, sorry, not that, from the standard position and then end up right here. And that angle is going to be 2 pi minus the reference pi over 3. And that angle will give us tangent value to be negative square root of 3. So our last angle is going to be 5 pi over 3. Again, I'm getting these values by putting this into common denominators. All right, so these are the solutions in this for this equation. As long as theta values are these, and these are all within this restriction 0 to 2 pi. So those are the theta values that will correspond to tangent to be positive square root of 3 or negative square root of 3. Again, there are two places tangent values are negative and two places they are positive. Okay, so that completes our answer for number 7. Moving on to number 8. So should give myself a little room over here. Okay, here we go. So for number 8, we're going to simplify this expression. So let's go ahead and factor. Now remember here we have a division between two fractions. So we're going to have to convert to a multiplication and reciprocate the second fraction. So we can write this as follows. So we got 2t plus 4 over t minus 1 times. Now I need to reciprocate this fraction. So this will become t squared minus 1 over t plus 2. And then you factor everything and cancel out any common factor from the numerator and denominator. All right, so for this right here, I can factor out a 2. So that'll give us 2 times t plus 2. Divided by the denominator, there's nothing to do, but I'm just going to throw in the parentheses. Times, now on the numerator of the second fraction, here I can factor that. That's a difference of two perfect squares. That factors into t plus 1 and t minus 1. And the denominator, I just have t plus 2. Again, I throw in extra parentheses. But now you start to cancel common factors. So here, t plus 2 cancels. Then t minus 1 cancel. Nothing else cancels, so we just rewrite what's left over. It's 2 times t plus 1. So there you have it. You can leave your answer here, or you can say, you can distribute out the 2. So that will give you 2t plus 2. Any of these answers are fine. All right, number 9. So for number 9, we're going to solve this equation. This is an exponential equation. All right, let's see how we can solve this. So we're going to go ahead and try to isolate the exponential term. So first thing I'm going to do is divide both sides by 2. All right, so once I have done that, I will have 7 on the left side plus e to the power of x plus 1, 100 divided by 2, that's a 50. And now I go ahead and subtract 7 on both sides. So I will have e to the x plus 1 is equal to 50 minus 7. That will give you 43. Now, the only way to bring down this exponent is to apply logarithm on both sides. So I'm going to go ahead and apply ln on both sides, natural log. So on the left side, e and ln will cancel each other. So you'll just have x plus 1. On the right, so you just have this number ln of 43. So remember, this is a number. And then to isolate x, I just subtract 1. So you'll have x is equal to ln of 43. put that in parentheses, minus 1, so that you don't combine that 1 with the 43 because they're two different numbers. That will be your answer for number 5. I'm sorry, number 9. All right, we're up to number 10 now. Find the inverse function of f of x. All right, so first thing you're going to do is replace f of x with y. So we have y is equal to 2 minus x cubed minus 5. And then you are going to switch x and y. So now this becomes x is equal to 2 minus y cubed over 5. And then your goal here is to solve for y. And that will be our inverse of f. So I'm going to go ahead and multiply both sides by 5. So this will give us 5x is equal to 2 minus y to the third. Now here I'm going to swap the places for y cubed and 5x so that I have y cubed as a positive term. So this will give me y cubed is equal to 2 minus 5x. And now I take cube root on both sides. So you'll have y is equal to the cube root of 2 minus 5x. All right, so this is your inverse function. So we're going to go ahead and call this as our inverse formula. So I'm just going to move that to the side. So our f inverse of x is equal to the cube root of 2 minus 5x. So that is our answer to number 10. Moving on to number 11. Number 11, we're going to solve this logarithmic equation. So I see two logarithms. There is a difference between them. Using the laws of logarithms, you combine it into a quotient of the input. So this will become the log base 4 of x plus 12 over x minus 3 is equal to 1. Now using the definition, we write this in exponential form. This is 4 to the power of 1 is equal to the input, which is x plus 12 over x minus 3. And then you solve for x. So I'm going to go ahead and multiply both sides by x minus 3. So continuing right here, so you'll have 4 times x minus 3 is equal to x plus 12. Here you distribute out the 4. You get 4x minus 12 is equal to x plus 12. I'm going to add 12 to both sides, subtract x from both sides. So you'll have 3x is equal to 24 divided by 3. You'll have x is equal to 8. And now you check your answer. So go ahead and plug in 8 into this x and this x. As long as the input is positive, it's a solution. So 8 plus 12, that's a positive number. 8 minus 3 is a positive number. Check. So this is a solution. So we can say our solution is x equals 8. All right, continuing with number 12, we have an application. 250 milligram of sample of a radioactive element decays to 190 milligrams in 60 hours. After how many hours will the sample decay to 125 milligrams? All right, so using this information right here, we're going to find the rate R. So let's go ahead and first find R. How is it decaying? So we start with 250, that's your initial amount. Let's call it PO. And then we know the amount after 60 hours happens to be 190 milligrams. So we use the model P of T is equal to PO e to the power of RT. We use the exponential decay model. I'm using this one because eventually when you solve it, you will get a negative value for R, so it'll represent decay. You could throw in the negative sign there if you want, but it's fine to go ahead with this model. So I'm going to plug in on the left side 190. That's the amount. We start with the initial amount 250. E to the power of R, we don't know, times T, that's 60. All right, now we go ahead and solve. So first thing you're going to do is divide by the initial amount. So when you divide both sides by the initial amount, you're going to get 19 over 25 is equal to e to the power of 60R. Now to bring down the power of the exponent, we're going to apply natural log. So we'll have ln of 19 over 25 is equal to, on the right side, e and ln will cancel. You just have 60 times r. Then divide by 60 on both sides. So you'll have r is equal to 1 over 60 times ln of 19 over 25. You could write 1 over 60 as an exponent for this, but that's okay. Let's just keep it this way. But of course, you can rewrite your answers in multiple ways, especially when you have logarithms involved. Okay, so that is our rate. So our model for this problem it's going to be the amount at any given time t is equal to the initial amount, which is 250 times e to the power of r, 1 over 60 times ln of 19 over 25 times t. All of that is on the exponent. Now let's answer the question. So after how many hours, meaning t, what is t, so that the sample will decay to 125? So I'm going to set this model equal to 125 and solve for t. So this is equal to 50 e to the power of 1 over 60 ln of 19 over 25 times t. So we're solving for t. Go ahead again solve, divide both sides by the initial amount. So you'll have 125 over 250, which is equivalent to 1/2. This is equal to e to the power of 1 over 60 ln of 19 over 25 times t. All right, so now we take ln on both sides. We apply ln and drop down the exponent. So let's give ourselves more room. Okay, so I'm going to continue right here. So I do ln on both sides. So I have ln of 1/2 is equal to 1 over 60 times ln of 19 over 25 times t. Remember, when you apply ln on both sides, on the left side, you get this number. On the right side, ln of e, they cancel each other. So you'll have just the exponent dropping down. Okay, now let's continue. So finally, we want to solve for t. So multiply both sides by 60. So you'll have 60 times ln of 1 over 2 is equal to ln of 19 over 25 times t. Then I divide it by ln of 19 over 25. So you'll have 60 ln of 1 over 2 divided by ln of 19 over 25 is equal to t. So that is the time it will take for the sample to decay to 125 milligrams. Again, you can write this answer in multiple ways. Like right here, this could be written ln of 1 minus ln of 2. Ln of 1 becomes 0. So ln of negative ln of 2 times 60 divided by ln of 19 over 25. But I think this is fine. You could leave it here. Okay, moving on to the next problem. Number 13. Let's go ahead and find the center and radius of this circle. So we're going to go ahead and complete the square. Let's rearrange the terms. So I'll put these two next to each other and then these two next to each other. The 10, we move it to this side. So you'll have x squared plus 6x, leave a space, plus y squared minus 4y is equal to negative 10. Now we complete the square, so we take half of this value and we square it. So that'll be 3 squared, that's 9. So we add 9 to both sides. For the y variable, we take half of this value and we square it. So that'll be negative 2. You square it, you get positive 4. You add 4 to both sides. All right, now you factor. So these guys will factor into x plus 3 squared. And these guys will factor into y minus 2 squared. And on the right-hand side, you add these up. So negative 10 plus 9, that's negative 1, plus 4, that's a 3. All right, so that is in standard form. Now we can identify the center of the circle. The center will have the coordinates negative 3, positive 2, and the radius is r, which will be the square root of this number right here. So positive square root of 3. So that is the answer to this question. All right, I hope this makes sense. All right, moving on to the next problem. Find an equation of the line that passes through the following points. So we need the slope. Let's call this x1, y1. Let's call this x2, y2. So first we need the slope of the line. So our slope is denoted by m. That is y2 minus y1 over x2 minus x1. Then we substitute those points as I labeled. Y2 is 6 minus y1, that's negative 2. X2 is 7 minus x1, that's negative 1. So the numerator we get 8, denominator also 8, so the slope is 1. All right, so using point slope form, we have the equation y minus y1 equals m times x minus x1. And you can use any of these points to write out the equation of the line. I'm going to use the first one since those I labeled x1 and y1. Feel free to use the second one if you like, no problem. So let's substitute m here and the points right here. So our equation of the line would be y minus y1, that's -2, is equal to m1, x minus x1, that's -1. Clearing out the negative signs, you have y plus 2 is equal to x, I guess, plus 1. Yeah, you don't need the parentheses, but I'm keeping it. Just wanted to keep them. There you go. That is our answer. All right, next problem, number 15. We are going to evaluate this inverse trig. So remember, this is a cosine inverse. So we want to know what is theta. So you ask yourself, what is theta? So that cosine of that theta gives you the value negative square root of 3/2. And also the theta is within its restricted interval for cosine 0 to pi, meaning our answer must be up here from 0 to pi. All right, so that is the question we ask ourselves. Now let's go ahead and work it out. So we call this, so here's how you should work. So cosine inverse of negative square root 3/2 is equal to some theta. We apply cosine to both sides, so we get cosine of what angle gives us negative square root of 3/2. So we know positive value for cosine. We know that when theta is in this quadrant 1, this theta right here, that is going to give us the positive square root of 3/2. So we know that theta must be pi over 6. So we know pi over 6. Note that cosine of pi over 6 gives you positive square root of 3/2. Now, if you use this as a reference angle, we can find the angle over here because we know that's going to give us the negative value of square root of 3/2. So that's what we want. So our theta must be pi minus pi over 6. And that'll give you 5 pi over 6. So that is the answer to this problem. And this is within the restricted boundary where theta must be 0 to pi. Now, if you try to give an answer that's on this quadrant, because cosine is also negative there, but that's outside the boundary of the inverse function. So it wouldn't make sense. So your answer must be in the second quadrant if the exact value is negative. So this is our answer for 15. Okay, we're up to number 16 right now. So we're going to solve this fractional equation. So every time you have an equation of this form, I like to get rid of the denominators. I also like to make the following note that x cannot equal to values that'll make this denominator 0 or this denominator 0. So if we get any of those solution, we're going to reject them. So we know x cannot equal to 2 or -2 because that's when these guys are 0 in the denominator. All right, so let's find out the LCD. The least common denominator will be 5 times x plus 2 times x minus 2. So you need a collection of this denominator, and this denominator to get rid of them completely. Okay, so now we take the LCD, multiply both sides of the equation by that. So the first equation, when you multiply by the LCD, x minus 2 will cancel. So you'll be left with the 5 times x plus 2. For the second fraction, x plus 2 will cancel out. So you'll have 5 times x minus 2. And the right-hand side, you'll have 5 canceled out. You'll have 6 times x plus 2 times x minus 2, which you can just expand and write it as x squared minus 4. All right, now you expand both sides. Here we distribute, here we distribute, here we distribute. So 5 times x, that's 5x, plus 5 times 2, that's 10. And then again, 5 times x, 5x, 5 times -2, -10 is equal to 6x squared minus 24. All right, now our goal is to move everything to one side where x squared is positive. So I'm going to move everything to the right side. So on the left side, you'll notice that these guys will cancel out. So you got a 10x on the left side. Move that to the right-hand side. So you have 0 equals 6x squared minus 10x minus 24. All right, so it's a quadratic equation. Now we're going to go ahead and solve either using factoring, completing the square, or using quadratic formula. So it looks like before we start factoring, it might be best to reduce the right-hand side by a factor of 2, since that's a common factor between them. So you can divide both sides by a 2. to reduce the number. So 0 over 2, that's going to be 0 on the left side. So we have 0 is equal to, you'll get 3x squared minus 5x minus 12. All right, so we can do that. We can just reduce numbers like that. So now, all right, I seem to run out of space. Can I just go ahead and shift this way? Okay, so now, now we can start to see if this is factorable or if now we can go ahead with the quadratic formula. But I still believe this is factorable. So let's see, let's put a 3x here. So I need bigger parentheses like that. And then we put x here because then this will give me 3x squared. All right, now I guess we can just play around with it. Let's put a 3 here and a 4 here because here I'm guessing these two are going to give me negative 12. Now I just need to check if the middle term works. So this is a 3x squared, 3x times negative 3, that's negative 9. And then 4x, that's positive 4x. So that would be a negative 5x. Good, so it works. So that is factorable. All right, that's nice. Now we set each factor to 0. So we'll get 3x plus 4 equals to 0. Subtract 4 on both sides. 3x is equal to negative 4. Divided by 3, you get x equals negative 4 over 3. That's one solution. Then we got x minus 3 is equal to 0. Add 3 to both sides, you get x equals 3. All right, so we got two set of solutions. Now let's go back and check, did we reject any of these? Well, seems like not. We rejected only these values. So that means indeed, these are our solutions. Okay, so that is the answer to number 16. Now let's move on to number 17. We're going to solve this inequality. So this is a nonlinear inequality. We're going to go ahead and factor. But before that, let's move everything to the left-hand side. So you'll have x cubed. X cubed. And then I subtract x squared, so that's negative x squared. Then I subtract 30x, that's minus 30x, less than 0. Okay, now we can pull out an x from each term. So you'll have x times x squared minus x minus 30 less than 0. And now we can factor. So this is x times, here again, you try to factor. You got x and x here, because that will be x squared. Now, I'll put a negative 5 and plus 4. Maybe not. That doesn't work. Let me do negative 5, positive 5, and minus 6. I think that will do the job. All right, let's check if this works. So again, x times x, that's x squared. X times negative 6, that's negative 6x. Here you got positive 5x, so that's a negative x when you add them up. And then 5 times negative 6, that's negative 30. All right, check. So I just did guessing and checking to factor. You could use other methods to get the factors. Okay, now let's get the zeros. So we get our zeros for this inequality. So you set this to 0, you get 0. And then you set this factor to 0, you get negative 5. And then the last factor, when you set it to 0, you'll get 6. So these are the zeros. Now you draw the real line and test each interval. So here we plot the zeros, so we get negative 5, 0, and 6 in order. So you have 4 intervals to test. Now each interval is going to be open because of this inequality. It's less than, if you have less than or greater than if you have a strict inequality. So the first interval we're going to test is negative infinity to negative 5. Then we're going to test negative 5 to 0, open, then 0 to 6, and then 6 to infinity. So we pick a test value and plug it back into, I like it in this form because it's easier to substitute values for x. Okay, so we want to see which interval it is positive or negative. So remember, we want our statement to be less than 0. You can take any of these. They're all equivalent. We want a less than 0, meaning we want negative intervals. Interval that gives us negative values. So let's pick a test value on the first interval. We can do negative 6. For the next interval, actually, let me put them on the bottom right here. And the next interval, we can do negative 1. The next interval, we can test 1. Anything convenient within the interval. Then the next interval, we can do 7. All right, so let's take negative 6 and substitute right here. Negative 6, negative 6, negative 6. So let's see what is the sign, meaning what is the value of it. So negative 6, when you plug it into x, it's negative. And negative 6 plus 5, that's a negative value. Negative 6 minus 6, that's also a negative value. So 3 negative values, the result is negative. So in this interval, we get a negative value. So I'll put a negative value. Then you do the same thing for the next interval. You substitute in place of x and see what the result is. So I'm going to substitute negative 1 for each x in my statement. So I get negative for the first. Let's just put negative, not negative 1. Second, negative 1 plus 5, we get positive value. Negative 1 minus 6, that's a negative value. So 2 negatives, that's a positive, times positive, that's positive. So we get positive results here. And then for 1, again, you do the same thing, substitute in place of x, see what the result is. So we plug in positive 1, positive 1, positive 1 for each x. So first positive 1, well, that's positive. Positive 1 plus 5, that's positive. 1 minus 6, that's a negative number. So 1 negative makes everything negative. And then from 7, let's plug in 7 into each x. So we plug in 7 here, 7 here, 7 here. So 7x, well, that's just a 7 positive number. So let's just put that. We don't need the actual value. We just want to know if it's positive or negative. 7 plus 5, that's positive number. 7 minus 6, that's a positive number. 3 positives, when you multiply them, you get a positive value. All right, so like I said initially, we want the inequality less than, right? Less than 0, meaning we want intervals that are negative. So we want this interval and this interval. So these are the solutions. So our solution to this problem, so our solutions are going to be from negative infinity to negative 5, union 0 to 6. So that will be the solutions to this problem. Okay, moving on to the next problem. Here you go, number 18. We're going to use this piecewise function to evaluate this function values. We're going to look at that specific subtraction. This is called the net change. So let's find f of 5. So f of 5, well, your input is 5, so you look to see which interval contains 5. 5 is bigger than 2, so it's this interval. So we're going to use this function to evaluate. So that will be 5 minus 5 squared. So I replace 5 in place of x right here. So this will give you 5 minus 5 squared, that's 25. That will give you negative 20. All right, then for f of negative 5, so you again look in this interval to see where negative 5 is. Negative 5 belongs to this interval, so you use this function to evaluate 10. There's no x2 input, so negative 5 will always be 10. F of negative 5 is 10. All right, so now we find the following operation. We do f of 5 minus f of negative 5. So f of 5, we got that to be negative 20. So this is negative 20 minus f of negative 5. We got that to be 10. This is 10. So that's going to give us negative 30. So our answer to this problem is negative 30. Okay, moving on to the next problem. So the graph belongs to the problem below. So here we're going to find the average rate of change. That's a formula we're going to use for this function between these values. All right, so the formula for average rate of change, the average rate of change, it is going to be f of b minus f of a over b minus a. That's the formula. Now we're using the function notation g, so I'm going to change these f into g's. So g of b minus g of a over b minus a. In other words, you take the function values, you subtract them, divided by b minus a, the x values or the t values in this problem. Okay, so the first t value, we're going to call it a. The second t value, we're going to call it b. So we need to find what these values are. So g of a would be g of 1. So I plug that into my function g. That's 8 over t. So that's 8 over 1, which is 8. Then for g of b, I evaluate g of 1 plus h, because that is my second value. We call it b. This is going to be 8 over 1 plus h. Now that doesn't simplify, so we leave it as it is. All right, so the average rate of change, you take the second function value, that's this one. And then we do minus g of a, 8, that's this one. Then we do b minus a. So you'll have 8, okay? So you'll have 8 over 1 plus h minus 8 all over b minus a. Our b is 1 plus h, our a is 1. Okay, now we simplify this fraction. So first you want to combine this into a single fraction. So you could write 8 as over 1 and then multiply by this denominator, top and bottom. So you multiply 8 with 1 plus h over 1 plus h to group them into a single fraction. And on the denominator, these guys will also cancel out. So you're going to get 8 minus 8 times 1 plus h over 1 plus h over h. And now here we distribute out the negative 8. So that's going to give us 8 minus 8h over 1 plus h over h. And then here again, we see these will cancel out. You'll be left with 8, negative 8h over 1 plus h over h. Now here I can change flip. So I keep the numerator, I keep the first fraction. I change this division to multiplication and I reciprocate that. So when you do that, all right, let's continue here. So you'll have negative 8h over 1 plus h times 1 over h. So I reciprocate the second fraction. Now I can freely cancel out common factor, h and h. So I'm left with simply negative 8 over 1 plus h. All right, that fits right into the answer box. There you have it. That is our answer to this problem. That is the average rate of change between those two t values. Okay, moving on to the next problem, number 20. For number 20, we have to use this graph right here to find the range of this function using interval notation. So range is the set of y values. So we look at the lowest y value, that's right here, 0 to where the graph exists. So as far as this point right here, and this is closed right here. So it's actually closed. So the range of this graph will be closed from 0 all the way to, so I think the y is scaled by 1. So this is a 1, 2, 3, 4, 5. And since this point is closed, we're good to close that endpoint. So 0 to 5, closed. So that is the range of this graph. Okay, all right, moving on to the next problem, 21. We're going to graph this. Let's use transformation to graph it. So here I see I have an absolute value with some transformation. So we're going to start with the graph of absolute value of x. And then we're going to do the following transformation. So this negative indicates it's a reflection over the x-axis. So this is a reflection over x-axis. It'll give us negative absolute value of x. And then you can do any transformation you like, this or that. So I'll go with, I guess, from left to right. So I will go with +7 inside the absolute values, which indicates we take our graph to the left. So we're going to go shift left 7 units. That will give us negative x plus 7. And then to get the final picture, we move up 1 unit. So our third transformation is to shift that graph up 1 unit. They'll give us the final picture, negative x plus 7 in absolute value plus 1. Okay, so let's do those shifts and see what we obtain. All right, so let's be careful with our graph. So at this point, you should know how to graph absolute value of x. It looks like a V passing through the origin. So the basic graph I'll do with a dotted line like this. So here's the absolute value of x. That's absolute value of x. Then I reflect it over the x-axis. So I obtain this graph right here. That's negative absolute value of x. And then so I guess I'm gonna erase these, that way we don't get overcrowded in the picture. And then I'm gonna go ahead and shift left 7 units. So if this was 0, 0, let's suppose this is 7. So 7 units to the left, so it's at -7. So here's my graph that was reflected and shifted, 7 units to the left. All right, so I'm gonna try to make a sketch. Okay. And then for the final picture, we go up 1 unit. So just 1 unit up right here. So our final picture, it's going to be passing through this point, -7, 1, and you just preserve the shape of the graph. Just like that. And eventually it's going to hit the y-axis down there. So you could label it if you want to. I think I'll label it, but let me finish the graph. So this point is -7, 1. It has x-intercepts here. You can solve for them as well. Since the question didn't ask, we're going to just leave them there, not label it. This is good enough. You could find this one. This one it's pretty easy to find. You let x equal 0. So if x is equal to 0, you take absolute value of 7. That's 7 times -1, -7 plus 1. That's a -6. So this point is actually -6. There you have it. This is the graph of f of x. Okay, I hope this makes sense. Continuing to the next problem. We have a composition to do for this problem. We're given h of x, f of x, g of x. We're going to do this composition. So g circle f circle h is g of f of h of x. So the first function you're going to start with is h of x. So I'm going to substitute h in here. H happens to be this guy right here. So you'll have g of f of h, which is x plus 1. So now you do f of that. So f is going to take x plus 1 as its input and plug it right in here where x is. So this is going to be g of, well, f is going to do 1 over the square root of x. X is x plus 1. X is h of x. And then g is going to take that and take this, plug it in here. That's what g is going to do. So our final result will look like this. So you'll have x squared minus 4 times x. Well, x is this new input right here. So I'm going to replace them. So this will look just like this. This is 1 over square root of x plus 1. So again, I replace 1 over square root of x plus 1 right here. And then I simplify. So it looks like the only thing we can do is simplify this one. Distribute that exponent to the 1 and to the square root. So that way the square root will cancel in the denominator. So your final simplified expression looks like this. You'll have 1 over x plus 1, since I cancel the square root with the square, minus 4 over the square root of x plus 1. And I think it's okay to leave it right here because you could combine them using common denominators, but this is okay. All right, now we move on to number 23. So we're almost to the end of the test. Hopefully you're doing okay getting these questions right. So number 23, we're going to find the maximum value of this graph. Now this is a parabola because we have x squared as the highest power of x. And since this coefficient is negative, it's a parabola facing down. So roughly sketching, it's going to look something like this. So we want to know what this number is. That is our maximum value. So we know we can find the vertex because that's also called the vertex of this parabola. When the vertex is obtained at x equals -b over 2a, we want to know the y value. So first we need to find when does it occur, what is the x value, and then we look for the y value. All right, so let's see what is a and b. So a we know is -1/2. That's the coefficient of x squared. B is -4. We don't need c, but c is 10. So you can write it out if you want. So we know this is going to be -b. So that's -4 over 2 times a is -1/2. The double negative is positive, so it's +4 over 2 times -1/2. That's a -1. So this is -4. So this value occurs at x equals -4, but we need to know the y value. So we're going to plug it into the function, get the y value. So f at -4, it's going to be -1/2 times -4 squared minus 4 times -4 plus 10. All right, so this will give us how much? -4 squared is a +16 divided by -2, that's a -8. And then -4 times -4, that's +16 and plus 10. So this will give us -8 plus 16, that's +8 plus 10, which gives us a value of 18. So our maximum value is 18. And it occurs at x equals -4, but we don't need that. We just want the value. Value means we want the y coordinates of that maximum point. Okay, moving on to the next problem, 24. Sketch the graph of this function. This is an exponential function, base 2. This negative is representing a reflection. This 10 plus 10 is representing a vertical shift. So again, using transformation of functions, we're going to start with 2 to the x, so the base is bigger than 1. Here, we'll do the reflection first. So again, reflect over the x-axis first, and then shift up 10 units. So that is our transformations to be applied. So I'm going to go ahead and draw my x and y axis like this. So 2 to the x looks like this. It's an exponentially growing function, base 2. This point right here is 1. It has a horizontal asymptote at y equals 0. Now we're going to reflect over the x-axis. So the graph will drop down like this. So it's going to look like this. That's the reflection. This is -2 to the x. So note that this point right here is now -1. And then we shift up 10 units. So as you're shifting up, you're also shifting the asymptote. So first I'm going to shift the asymptote 10 units up. So you're going to add 10 to it. And then this new intercept, you're going to add 10 to it. So it's going to be at 9. So shift everything up by 10 units. So the new horizontal asymptote will be right here. Let's just call this the new horizontal asymptote. So I'll use dotted line to indicate that. So the reason I like to draw the asymptote first, so that way I don't go beyond that point when I'm sketching. So this is y equals 10, and this point gets shifted 10 units up. So it's going to be right up here. Let's call that 9. Then you just preserve the shape of the graph, something like that. So as you can see here, it's getting closer to the asymptote. Here it's just going downward to -infinity. So that is our final sketch. So I'm going to go ahead and erase that. And this is going to be the final sketch. This is f of x is equal to -2 to the x plus 10. Okay, you could label this intercept again if you want to. Since the question didn't ask, we will just leave it like this. But do know how to find intercepts. They're important. Okay, number 25. This is our last question for the test. We're almost to the end. So we're going to graph a trig functions for graphing cosine. All right, so first thing you want to write down is the amplitude. So the amplitude of this graph is the absolute value of that number, which is 4. And then we find the period of this graph. This is period using the formula 2 pi over k. K is this number right here. It's the coefficient in front of your variable x. It's 1/4. So I substitute this is 2 pi over 1/4. Again, if you simplify this, you'll get 8 pi because 2 pi times 4 is 8 pi. All right, so this graph is being stretched horizontally by a factor of 1/4 right there. So the period is now extended to 8 pi instead of 2 pi. So we know the basic cosine graph completes one cycle from 0 to 2 pi. Here, the interval of one period of this graph, it's going to go from 0 to 8 pi. So it's a graph that's being stretched horizontally. So I guess it's very hard to show that when you're graphing by hand, but I'll do my best to show. So I'm going to label this 8 pi. So you subdivide this into 4 subinterval with equal length. So you take the period, you divide it by 4. So the length of each interval is usually determined by taking the period, which is 8 pi, you divide it by 4. So that's going to be 2 pi. So this is a 2 pi plus another 2 pi, that's 4 pi plus another 2 pi, that's 6 pi, and then plus another 2 pi, you get to here. Okay, now you just preserve the shape. The amplitude is 4. So that means the maximum we're going to reach is a 4. The minimum we're going to reach is a -4. And then we know cosine starts at its maximum when the angle value is 0. So we're going to start here, drop down to 0 at 2 pi, then drop down to -4 at 4 pi, then go up to 0 at 6 pi, and then 8 pi, you go back to the maximum. Then you connect these points, you get your cosine of this function, cosine of 1/4 x times 4. So it looks something like that. Sorry, not the best graph, but hopefully you can do better. So this is our graph fork. And then of course the graph continues on both directions, but we have just drawn one period since the question says one period. Okay, there you have it. This is our end of the test. I hope you understood the concepts, at least got a lot of the questions correct. Leave your comments below if you see any typo or any errors I have made. Thanks so much for watching. See you next time. Take care, everyone.